Hi and welcome to a video tutorial on learning limits involving trigonometry, or how to take limits involving trigonometry. So when approaching a limit involving a trigonometric expression, it's best to start with the same first step. Substitute the intended value of x. The tough part is remembering the values of the trig functions on the unit circle. So what we're going to do is fill in the unit circles with important values to remember. Then we're going to compute each limit, which I have 13 examples for us below. So the first values that I would memorize is that this is basically 0 radians, and this would be pi halves radians, and this would be pi radians, and 3 pi halves radians. And now I'm just going to try my best to convince you that we're just counting by 1/2. 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, and of course 0 is the same thing as 2 pi, so calling this 4 pi halves is the same as the 2 pi. Okay, so what I want to do is I want to split this in half so that you can start considering how to use the unit circle effectively. So I'm going to cut this one in half, and again that's a fourth, and then this will be another fourth of the circle. So when I say I'm cutting the half in half, this is pi halves, so I'm cutting it in half again, so this will be a fourth, another fourth, another fourth, another fourth. We'll cut this. I'm trying my best to cut it exactly in half, so it looks good on the video, right? Okay, so up here this one's going to be called pi over 4. And of course this one now, it's not called pi, it is called pi halves, but if I'm counting by 1/4, then wouldn't it make sense to call this 2 pi fourths? So this next red one would be called 3 pi fourths. And the next black one is actually, I could call it 4 pi fourths, right? And then 5 pi fourths. This 6 pi fourths gets reduced. 7 pi fourths. And then 8 pi fourths. Remember, 8 pi fourths is the same as 2 pi. Okay, so I haven't really talked to you about the values of sine and cosine at these values, so I guess I'll switch to a different color. Now every point is going to be cosine theta, comma, sine theta. Okay, and I'm just going to use these right now. So this point out here is the point 1, 0. So the cosine value at 0 is 1. The sine value at 0 is 0. The next one is still cosine theta, sine theta, but those values are going to be root 2 over 2, root 2 over 2. The next one is 0, comma 1. All right. The next point over here, we can refer to this one and basically just make the x-coordinate negative. We can refer back to this one and make the x-coordinate negative. We can refer back to this pi fourths for this one, and this would be both of the coordinates are negative. And then 3 pi halves, that'd be 0, negative 1. And then this 7 pi fourths, we just refer back to this one, and we make the positive x value with a negative y value. Okay, so this is essentially all the information that we need to count effectively for anything dealing with pi fourths. Okay, unfortunately there are other values that we have to memorize as well, right? So what if we go out here and we, instead of cutting it exactly in half, what if we care about the 30-degree measure? So the 30-degree measure, I'll do my best. Oops, there we go. And so I'm not calling that perfect. That's definitely not perfect. That's a little too wide there in the middle, but doing my best here. So just do your best when you cut yours up. Ugh, very bad. Okay, so maybe I'll do better freehand. Okay, and I wish I had a different, maybe I should have used 2 different colors there. Alright. But they're related to each other, so that's why I stuck with the same color. So we know that this is a 30-degree angle. I might have mentioned that. But the reason I'm choosing 30 degrees first off is that it goes into 180, right? So 30 degrees. This is just going to look, this just looks too bad to me. So let me fix this. Okay, so at this point I've done a little bit of doctoring. So I want to walk through 30-degree rotations. So 30 degrees goes into 180, and if you did 180 divided by 30, you'd actually get 6. What this means is that you're going to have 6 pi pieces. Oops, 3, 4, 5, and 6. You're going to have 6 pieces, and these pieces should be congruent, but I did not draw them very nicely, so they don't appear to be congruent. But I'm doing the best that I can, okay, with just trying to eyeball this. So here we go. At this piece, it's pi 6, and at the next one, it would be 2 pi 6, but 2 pi 6 reduces to, pi 6. 2 pi 6 reduces to pi thirds. Now 3 pi 6, well, that'd be pi halves. 4 pi 6, well, that'd be 2 pi over 3. 5 pi 6, I'm just going to rewrite as 5 pi 6. And 6 pi 6, well, I'm just going to write pi for that one. Okay, so you'll notice that we already had pi halves memorized, and that had to be reduced. We already had pi memorized, and that had to be reduced. But there was another one in there that had to be reduced as well, and that's called pi thirds, okay? So if you look at just the blue numbers, there's pi thirds, and here's 2 pi thirds, so I think that you could guess what other pi thirds would come next. Well, it would be 3 pi thirds, right? But that's pi. So let's keep going. I bet that this one then would be either 4 pi thirds or something like that, right? But let's count. Let's count by sixths. This is the way I do it. This is 6 pi 6, so this is actually going to be 7 pi 6, okay? And then 8 pi 6, that's going to reduce to 4 pi thirds. There's where your 4 pi thirds shows up. And then, so we're counting by sixths though. So 8 pi 6, 9 pi 6, well, that's 3 pi halves. 10 pi 6, well, that's 5 pi thirds. And 11 pi 6. Okay, so basically I'm just teaching you how to count by 1/6. But if you're counting by 1/6, notice that you have some reduced fractions in there. 4 pi thirds is one of those reduced fractions. 3 pi halves is one of those fractions, but we already have that one memorized. And then 5 pi thirds is another one of those that's memorized. So now all we have to do then is just find out 2 more angles. The pi 6 angle and then the pi thirds. Well, we need to find the sine and cosine values of those angles. Well, at pi 6, it appears to me that the x-coordinate would be longer than the y-coordinate, right? The length of this is longer. So if the length of that is longer, then the root 3 goes on top of the 2. So it'll be root 3 over 2 and then 1 over 2. This is a longer measurement here. The root 3 over 2 is. Okay, if you use that same logic and you look at the next triangle on the list, this one that goes up here at pi thirds, notice that the y value is the longer one this time. Okay, so if the y value is the longer one, then when we write our coordinate, 1/2 the shorter one is going to come in front and the longer one will come in the denominator. Notice that both points are positive because they're in the first quadrant. So if I needed to go to any other point, let's just say I wanted to go to 4 pi thirds because I have room on the paper for this, right? So if I want to go to 4 pi thirds and I wanted to find the sine value of 4 pi thirds, well, I can think, okay, 1 pi thirds, 2 pi thirds, 3 pi thirds is at pi, so I just need to go to 4 pi thirds. And I know that 4 pi thirds is going to be in the third quadrant. And this is in my brain. All of this is happening in my brain. 3 pi thirds. And then I come 4 pi thirds, third quadrant. Then I think to myself, all right, in pi thirds, at pi thirds, the y value is longer. So that means that the sine value is going to be √3/2, but I need to do negative. Okay, so let's just say I wanted sine 4 pi thirds. I think to myself that it is negative sine pi thirds. Okay, so basically I just need to compute what sine pi thirds is, negative √2/2. Okay. So that is about it for this video. This video is going to get too long if I go ahead and get into the examples. So I'm going to stop right there. This is your introduction to solving limits involving trigonometry.